Hello everyone. In this video, we'll understand how do we proceed with the quick sort algorithm using divide and conquer method. Quick sort algorithm is the fastest known sorting algorithm in practice. It is a divide and conquer recursive algorithm. This works on the method of partitioning. And when we do the partitioning, we will ensure that all the elements to the left of the partition is less than the elements less than the right of the partition. So in this, the first element, we will be assuming it as the pivot element. Suppose if we have n elements to be sorted, the first element will be considered as the pivot element, and the remaining n minus 1 elements are compared with this pivot element so that the pivot element can be placed at an appropriate position and all the elements are also placed at an appropriate position. So for this, two variables I and j are maintained. The variable I is made to point the second element and j is made to point the last element. And we will now understand how this algorithm works with an example. This is the example. Index is given from 0 to 5 and array elements are given as 45, 36, 15, 92, 35 and 71. These are the numbers which needs to be sorted. So here the low value, that is this low index, is considered as low value, and this 5 is considered as the high or high index value. The initial settings for I, j and pivot will be as shown below. Means pivot, the first element is considered as pivot. That means this A of low is your pivot element, and I is low, that is this 0 plus 1. That means this 1 is going to be considered as I, and the last element is considered as high. So that is what is written here, low here and high here. And this is your I, this index, and the j index is this 5. And pivot is your 0 or the first element, which is 45. This pivot is compared with the element starting from AI. AI means this array elements are considered to be AI. So AI, when they say we are going to compare with each of the ith element, means first you will compare with 36, then you will compare. If it moves here, I moves here, means this will become AI. If pivot is greater than or equal to AI, we increment I, else at that point we stop incrementing I. Then the variable j will move from right to left by comparing pivot with aj. If pivot is less than aj, we decrement j, else at that point we stop decrementing j. After stopping increment of I and decrement of j, if I is less than j, then what we do is we swap ai and aj and continue the process. Else, otherwise, we swap aj and the pivot element and return to j. Means at this point, we conclude that the pivot will reach its correct position, which can be verified also. Now, subsequently, we will divide the table into two parts, that is two subarrays, and repeat the same process. So let us understand how do we proceed with the same example. Step 1, we started with this 45 as pivot and the next element as your I, next element as your j. First thing is you check the pivot, whether it is greater than or equal to AI, means whether 45 is greater than or equal to 36. Yes, it is true. That means you increment I, means initially I was 1, it will become now 2. Now in step 2, you compare again pivot with the AI now it is 15. Now you see whether 45 is greater than or equal to 15. Yes, it is true. That means you will increment the I value further. Earlier it was 2, now it will become 2 plus 1, so it will become 3. In step 3, again, you will compare the pivot, that is 45, with this AI, which is 92. You notice that 45 is not greater than 92. That means it is false. So what you do, you stop incrementing I. Now you start with right to left, that is J, you will start. So you will compare now pivot, that is this 45, whether it is lesser than AJ or not. AJ means now it is 71. So 45, is it lesser than 71? Yes, it is true. And hence what you do, you decrement the J value, means 5 will become now 4. That is why J is 4 here. Then subsequently, In step 5, what you do is you again check the pivot whether it is less than AJ or not. Means 45, is it less than 35? No, it is false. So we stop decrementing J. Now, since that we stopped incrementing and decrementing I and J respectively, we check whether I is less than J or not. Means here I is 3, J is 4. Is it less? Yes, it is less. Then what we have to do? We need to swap AI and AJ and continue the process. Means swapping AI and AJ means swapping this 92 and 35 in the next step. So 35 came here, 92 went here. So this becomes your swapped elements, means 35 and 92 got swapped. Now again, you are repeating the process, means check whether the pivot is greater than or equal to AI, means 45 is greater than or equal to 35. Yes, it is true. Hence, you move one step ahead, means you increment. I now it is 3, it will become now 4. Means I and J will occupy the same position now. Next, again, you will check whether this pivot, is it greater than AI, greater than or equal to AI or not? Means 45, is it greater than or equal to 92? No, it is false. So you stop incrementing I. Then now you will start with J. So in step 9, what you do is check whether the pivot is less than AJ or not. AJ means it is now 92, means 45. Is it less than 92? Yes, it is true. That means you can decrement J. So J now it is 4, it will become now 3. So J became 3 now. And in step 10, further, you check whether the pivot is, that is 45, is less than 35 or not. It is false. So you stop decrementing now J also. Now that you stopped both incrementing of I and decrementing of J, we check again whether I is less than J. I is 4 now, J is 3 now, so it is false. So when it is false, what you do is swap AJ and pivot. So that means you will swap AJ, that is 35, and pivot, which is 45. Means 35 will go there, 45 will come here. 35 has come here, 45 has come here. Now you can say that the element 45 has reached its correct position. How we say that? You may notice that the elements before 45 are all less than 45, 35, 36, 15, and elements to the right of 45 are all greater than 45, 92. But it may not be in order. It is not exactly in order. Here also it's not exactly in order. But one thing is, we are sure that 45 is in its correct position. So this you declare it as a J. Based on the J value, we will divide now this table into 2 parts, means subarrays. You will do it. So one part will be whatever is before 45, one part will be after 45. So I segregated the elements, means from low, that is 0, to J minus 1, because this is your Jth position. J minus 1 means 0, 1, 2. And then J plus 1 to high means J is 3, J plus 1 means 4 and 5. So 4 and 5 and whatever elements are there. Now again, we will be adopting the same procedure for both these subarrays as below. First, we will take this subarray, and again, the first element will be considered as pivot. The second element will be considered as I. Third element will be considered as J. You start with checking pivot, is it greater than or equal to AI or not? Means whether 35 is greater than or equal to 36. It is false. So no increment for I done. Now we will start with J. Whether pivot is less than AJ. AJ means whether 35 is less than 15. That is also false, since no decrement done for J. Since we stopped increment of I and decrement of J, we can check whether I is less than J. Here, I is 1, J is 2. So it is less than, 1 is less than 2. So it is true. So we will be swapping AI and AJ. Means this 15 will come here, 36 will go there. That is what is done here. Now again, we have to redo. We have to continue the process. Whether pivot, that is 35, is greater than or equal to AI. Yes, it is true. So we will increment it. Means I we will be increment. We will increment I, which means I is now 1. It will become now 2. Then further, whether pivot is greater than or equal to AI, means 35, is it greater than or equal to 36? It is false. So we stop incrementing I. Now we'll start with the J. Checking whether pivot, that is 35, is it less than AJ or not? Means pivot is 35, is it less than 36? Yes, it is true. That means we will decrement J. Means J is now 2, it will become now reduced to 1. So J will come here. Now, whether pivot is less than Aj, means this 35, is it less than 15? False. So we will stop decrementing J. Now we had already stopped decrementing I and incrementing I and decrementing J. We will now check whether I is less than J. 2, is it less than 1? No, it is false. So we have to swap now Aj and pivot. That means this Aj is 15, pivot is 35. So we'll be swapping this 15 and 35. When we do that, now we understood that 35 is in its correct position because the number which is to the left of 35 is lesser than 35 and to the right of 35 is above 35. And by seeing this, you can also find it in order, right? Then again, now in the second subarray, whatever we created that time, this second subarray we are taking. Yeah. So first step, you consider this 92 as pivot and this 71 as I, even that becomes the last also. So J also will be the same thing only. Whether pivot is greater than or equal to AI means is 92, is it greater than or equal to 71? Yes, it is true. But there is no next position to increment I, means there is no next position. So whether pivot is, so you cannot do increment now. Pivot is less than Aj, that means 92, is it less than 71? It is false. So no decrement can be done for J. So check whether if I is less than J, no, phi is less than phi, no, it is false. So you have to swap pivot and Aj, means 92 and 71 has to be swapped, means it will become 71 and 92. Now, combining the results of steps 11, initial pivot, initial J value, whatever you found, which was 45, that is in step 11, and step 18 is here. This is what it is. So if I combine 18, 11, and this 20, the sorted array will become now 15, 35, 36, 45, 71, and 92. So this is the way this particular quick sort algorithm works. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.